Today we're going to talk about how to find zeros of polynomial functions. So a polynomial function has exponents for the variables in it. And what it means to find the zeros is it's finding where the function crosses the x-axis. And we don't always have to do this by graphing the function. We can actually do this by factoring the function if we just have the equation for the function. So when we are trying to find the x-intercepts, we want to think of y being equal to 0. So we're going to plug in a 0 for y, and we're going to take our expression and factor by grouping. And the reason we're going to factor by grouping is because we have 4 terms in all of these expressions, which is fairly common. So with grouping, we split the expression down the middle, ignoring the 0. You've probably done this in Algebra 1, just might have been a while. And then we look for the greatest common factor on each side. So over here, 5 and 3 don't have a greatest common factor, but they both have x's. And they at least have 2 x's because that one has 3 and that one has 2. So we can factor out 2 of the x's. So when we divide, we subtract the exponents. If you don't remember that or recall that, you can always write it out. 3 x's on top, 2 x's on bottom, they cancel out. And there's 1 x left on the top. And 5 drops down. So we have 5x when we divide that. Here we drop our 3 down, and then all of our x's would cancel out, so just 5x plus 3. And we're going to put our greatest common factor, or whatever we divided by, on the outside. So now we have to do the same thing on the opposite side. You may notice that 5 and 3 do not have a greatest common factor, and they also do not both have an x. But when this happens, we can divide by 1, and in particular, a -1, since this one is negative. Even if this one was not negative, negatives are really pesky to work with, and we want to make sure that our problem works out nicely. So if this third term is a negative, make sure you divide by a negative for both of them. And you'll see why that works out here in a second. Because a positive 5 divided by, or a negative 5 divided by a -1 is a positive 5x. Dropping that x down, and -3 divided by -1 is positive 3. Which if you look closely at your parentheses, they match. And that would not have happened if we would have divided by a positive 1. Drop your greatest common factor down. And then for our final step, when we were in Algebra 1, we took our greatest common factors and we put them together in their own parentheses. So x squared minus 1, and then 5x plus 3. And if you were to actually FOIL or multiply that out, you would get back up to this expression. Usually, since it's set equal to 0, we would set both of these equal to 0 and solve. There's a couple ways you can do this, but since this factors further, because it still has this x squared in it, we know that if we wrote this out as x squared plus 0x minus 1, we could find the numbers that multiply to -1 and add or subtract to 0, which is 1 minus 1. So this expression can be factored down to x plus 1, x minus 1, taking the 2 numbers from in the big X and listing them out, and our 5x plus 3. So we have a factored expression, and it's all set equal to 0. So to find the zeros or the x-intercepts, we would set each of these equal to 0. I'm going to write on to the next problem a little bit. So 5x plus 3 equals 0. If you were solving that, you would take away 3 to isolate the 5x. 0 minus 3 is -3. and then divide both sides by 5 to get rid of that 5. So this is one of your solutions. You can leave it as a fraction or you can write it as a decimal. The other two, you can simply take the opposite of what's in parentheses. Since it's a one-step equation, you know you'd be subtracting the 1 over, so it'd be x is -1, and vice versa, the other answer, you'd be adding 1 over. So it'd be x equals +1. So the answer, or the final answer to this, is these 3 x values after you set them all equal to 0. We're going to stick with doing the odds so we have a little bit more space, but the evens you can practice on your own if you need a little bit more. So for number 3 here, I'm going to do that same thing. We're going to ignore the y and put in a little bit of a 0 since we're solving for the x-intercepts, and y would be 0. If you're missing a term or a coefficient rather, you can put in an invisible 1. We'll start our problem out by splitting it down the middle, ignoring the 0, and factoring out our greatest common factor, which in this case is 4. And they both have x squared. So it's always the smallest exponent of the two. 4 divided by 4 is 1. You don't really have to write that, but just in case. And then if we subtracted the exponents, we'd get x1 or just x. 12 divided by 4 is 3. And the x's will cancel. And then we'll put our GCF on the outside. Over here, same thing, you have a negative again. So if that third term is negative, you want to make sure you divide by a -1. And if it were positive, you would divide by a positive. That'll get you a +1 x, because the negative divided by negative is positive. And same thing over here, a +3. And then your -1 can carry down out front. Here, your two GCFs can bundle together. So we'll have a 4x squared minus 1 in its own parenthesis, and your 1x plus 3, or even just your x plus 3. When in doubt, you could check this by FOILing, doing first times first, outer times outer, inner inner, and last last, and you would get back to this expression. So we're breaking it down so we can solve for the zeros. This one, if you set it equal to 0, is pretty easy to solve because you would take x plus 3 equal to 0. But this one is a little bit different. So there's two ways you can do this. You can factor this further because we know that it has an x squared. So this one, we know a number times a number equals x squared, and there's a 0x in the middle. So we need the numbers to be the same. So we need 2 times 2 to be 4, and then 1 times 1 to be -1. And since it's a -1, we're going to make 1 a positive and 1 a negative. So this is one way you can factor this. Since we know there's that invisible 0x in the middle, these numbers need to be the same. And then they have to be opposite signs so you could get a -1 at the end of it. And then you would bring your 1x plus 3 down, and all three of these would be set equal to 0 individually to solve for x. If you didn't really like that factoring of 4x squared minus 1, there's one other way you could have done that. You could have went right to setting 4x squared minus 1 equal to 0, and we'll just put that over here. And then you could add the 1 over, get rid of the 4 by dividing, which is 0.25. You'd still have this squared, so you'd have to take the square root. And the square root of 1/4 I don't know off the top of my head, but you could do that in your calculator, or you could take the square root of the top, which is 1, and the square root of the bottom, which is 2. So if you plug that in your calculator, it should get you 0.5. So that's one way you could do it. Or you could factor it down further. Technically, when you take the square root of a number, you think it's only positive, but since 0.5 positive times 0.5 positive would get you back to 1/4, you could also have negative 0.5. So that's one way you could find your answers if you don't really like factoring. But personally, this makes a lot of sense to me because 2 times 2 is 4 and 1 times 1 is -1. And I know the middle term x cancels, which that 2x would cancel with that -2x if you multiplied it out. So if I set all of these equal to 0, I'm going to write on to the next one. We can just kind of cross that out. And you can do that one on your own for some extra practice. If we set this equal to 0, we would get a -1 and then have to divide by 2. So it'd be x equals -1/2, which is the same thing we got down here, the negative. And then since this is the same exact equation, but it has a -1, if we added that 1 over, we would get 2x equals 1 divided by 2. So x would be a positive 1/2. The last one, you can do that one in your head like we did up here. It's always the opposite of whatever number is there because you would have to subtract the 3 to set it equal to 0. If you need that shown, x plus 3 equals 0, subtract 3, and the answer was x is -3. So you have 3 answers again. That one was a little bit harder with the factoring. So if you do choose this way, just stay consistent and do what works best for you. We're going to do this one down here, and then I'm going to leave some for you to practice. I didn't realize, but all my examples had the third term as negative. So if this term is ever positive, you can divide by a positive. We just want to make sure that these terms and parentheses match each other. So here we will go ahead and write out our expression, and we will split it down the middle. Over here, they don't have a GCF other than the variable squared. And over here, they don't have a GCF other than -1. So when we divide, we have a 1x1 or just x and a +4 left over. Because those x squareds cancel. And our x squared goes on the front. Over here, we're left with a positive. Oh, that one's kind of weird. Oh, I see where I messed up. 3 divided by 1 is 3. You might have caught that. So this would be a 3x plus 4, which matches this, and that's how I knew I was wrong. And the -1 on the outside. So we have x squared minus 1 is in a parenthesis, and our repeating expression goes in its own. And then we can set these equal to 0 directly and solve, or we can factor this further. So if you want to set them both equal to 0 and solve, you could go ahead and write x squared minus 1 equals 0 and just solve for x squared. Or in my opinion, I think it's a little bit easier to go right to x plus 1, x minus 1, because we know there's a 0x in the middle. So anytime you have something without that x term, it's a 0 in the middle. So you're finding the numbers that multiply to -1 and add to 0, which is 1 and -1. So this would be the opposite. When you set it equal to 0, you get x equals -1. This one would end up being x equals +1 when you set it equal to 0. And this one you might actually have to write out and subtract the 4. and divide by the 3. So those are your 3 answers. Might do one more with you guys just to make sure the GCF part makes sense. So for this one over here, they both, again, have x squared, so we can divide by that. Over here, it's a negative, but instead of it being a 1, since both of these numbers are divisible by 4, we can make it a -4. Once again, it's negative because we follow suit on this sign. Put your GCF out front and your solution in the parentheses. So we're left with a 4x when we subtract the exponents. And everything cancels over here, so we'll leave 1 as a placeholder. Negative divided by negative is a positive 4x. Leave myself some space for my GCF, which is -4. And -4 divided by -4 is +1. So these two, if they don't match, go back and divide by something bigger or different. So we combine our two GCFs, x squared minus 4, and our repeater expression only has to go once because this is breaking out the distributive property. We can set both of these equal to 0, or we can factor this one further. Since we know 2 times 2 is 4, and they have to be the same number opposite signs for this type of factoring, we knew x plus 2, x minus 2, and 4x plus 1. If x plus 2 is set equal to 0, x will end up being -2, or the opposite. Same thing here, it'll end up being the opposite. And then for this one here, you might have to show it, but you can subtract the 1. So it'd be 4x equals -1. And to get rid of that 4, divide by 4, either leaving it as a fraction, sorry, I wrote on top of that, or you could make it a decimal by dividing top by bottom. So this is how you solve for the zeros using factoring by grouping. As always, if you need to pause the video and rewatch, please feel free to do so or ask any questions you may have.